How it's going to work. So each panelist is going to have roughly 10 minutes to give a short presentation about the kind of research that they do and what life is as a researcher. I've been asked to be merciless with keeping with time so that we have time to get to questions after. So after the presentations are done, I have a few kind of follow-up questions, but we'll open the floor to all of you so you can ask your questions to all of our panelists. So with that, we can move right on to the presentations. I'll let the different speakers introduce themselves. So the order I have here, let's go with that. So that would mean Dr. Gabrielle Lam is first.
Sure. Hi, everyone. And thank you so much for having me. I'm just going to share my screen. I'm going to share my screen. Give me one moment. And there we go. Okay. So good afternoon, everybody. And I just wanted to say it's an honor to be here. Fantastic job from the organizing committee for putting this together. Just seeing the lineup of speakers, super excited, and it's just a great event that you guys have pulled together. So my name is Gabby. I'm an assistant professor of teaching at UBC at the School of Biomedical Engineering. And I was asked to kind of pull together a couple slides to kind of describe my journey, my academic journey, what I do right now, as well as the reason why I do what I do. So here are a couple slides, but I'm hopefully making this a bit of a dialogue. So if any questions, feel free to just pop that in the chat, and happy to talk about those. So first of all, a little bit about my educational journey. Obviously, there are quite a few things on the side that kind of led to my journey into a role at UBC, but I'll talk about that. Starting off with my undergraduate degree in materials engineering at U of A. So my hometown is actually in Edmonton, Alberta, and I did my undergraduate degree there at the University of Alberta. I had a tremendous interest in biomedical engineering and just understanding that, you know, biomedical engineers can have a tremendous impact on people's lives and their health. And so I was really interested particularly in tissue engineering and regenerative medicine. So I was incredibly focused in the sense that I chose materials engineering specialized in biomedical option at U of A. And actually there's a picture of the campus, not my own picture, but I had a look and saw this beautiful one. This is the engineering complex at U of A. What it usually looks like is actually the one on the right, because we've got quite a bit of snow. It's a bit chilly there. During that time, went through the undergraduate degree, and I would say, you know, looking back, made some good choices and made some bad choices. And so reflecting on that in the sense that, you know, I was incredibly focused and I really wanted to get into research. One thing that I kind of closed myself off from doing is being open to things like co-op positions. I knew a lot of my friends were going into oil and gas, for example, and I had laser sharp focus and wanted just to do biomedical engineering and research in that area. And looking back, I kind of wish I was able to take some of those opportunities and just broaden my scope a little bit. But at the same time, I had the opportunity during the summer months to actually focus on research stints. So I had undergraduate research awards. You might have heard NSERC awards or similar ones, where you can apply for those and then work with supervisors in specific fields that you're interested in. So during the summer months, actually quite a few of them, 3 of the summers, I was able to link up with someone who worked in rehabilitation hospitals. And so during that time, what I was incredibly fascinated by was just how the engineers were able to interface with the hospital settings, with patients. So specifically, I was working on scoliosis. So that's kind of a deformation or a malformation of the spine. I think it caused quite a few different complications in people. But seeing how the technology that's developed in the lab can then be brought directly into the lab and have tremendous impact on people's lives was quite eye-opening. And I would say, you know, actually, in my summer opportunities, I really opened my eyes to just the impact that biomedical engineers can have on people. And so some of those different summer research experiences led me to some international experience as well. So moving from rehabilitation hospitals to hospitals in overseas, and then also working with a researcher in Hong Kong, China, where they actually worked with orthopedic implants as well. And so that's when I had my first taste of biomaterials and how materials can really interface with the body and the challenges that are associated with it, as well as some of the exciting opportunities in that field. And so afterwards, that kind of really spurred my interest in diving into graduate studies. So that led me to Toronto, another relatively cold city as well, but I've got some pictures up there of the campus. And the one on the right is the building that I spent most of my time in. So I did work in the biomedical engineering research field with a supervisor by the name of Michael Sefton. So he's kind of the grandfather behind tissue engineering, one of the grandfathers behind tissue engineering, and really, really excited, really wanted to work with him and learned quite a bit. And so I can definitely tell you a little bit about my PhD work there. I worked in tissue engineering field and looking at how we could assemble tiny little microtissues, so tissues that are smaller than the millimeter size. And because of that, they're injectable. So minimally invasively, you can inject underneath the skin, and I worked a lot with mice as well. So looked at how these microtissues could self-assemble and how they could contribute to vascularization or driving blood vessel formation in the tissue. Because it's great if you can, you can print and create the interesting architecture that you want outside of the body. But once you implant it, you have to be able to sustain any therapeutic cells that you're trying to introduce into the body. So the vascular structure is really important in that way. And so my specific PhD project, starting from my master's, was actually something that I drove. It was quite new and different from the work that was done previously in the labs. And so I was looking at oxygen sensing mechanisms and how we could use that either to turn down or to turn up the vascularization, in a nutshell. So I worked a lot with animals, with mice, in vivo work. I worked with viruses in order to genetically engineer our cells, but also with pharmacologics, so drugs as well, to tune that, and looking at how we could actually modulate the vascularization process in these microtissues that are implanted underneath the skin of mice. So that's the crux of my my PhD work. But on the side, I have to say, like you see in the title there, it's my quote educational journey. But there's a lot happening, I'd say, outside of academics that also really paved the way for my interest in an academic job. And so that included, number one, being quite involved in residence. So at U of A, I was living at home. And so I never had the experience of living in a residence, a student dormitory. Being in Toronto, though, I was presented with the opportunity. I actively sought as well an opportunity. And obviously, it always helps for grad students to have some extra money in order to work as a residence assistant in a dormitory or a student residence. And so I had the opportunity to see, and it really opened my eyes to how challenging the university experience can be, but also how gratifying, and the communities that can be created and how you can support students through mental health issues as well as through academic challenges. And so I think a lot of my learning, apart from just my PhD, actually came from those experiences as well. And so from there, I joined University of British Columbia. Vancouver has been my new home for the past 2 and a bit years, and really enjoy it. Fantastic group of students. An exciting program as well. So the School of Biomedical Engineering is relatively new, 2 years new as well. And just creating the curriculum that's involved in that, and working with students, undergraduates as well as graduate students, has been incredibly rewarding for me. How am I for time? Just so that I don't go over time.
You have another minute if you want.
Okay, all right, I talk too much. So we think about academia probably as the ivory tower. I've touched on a few things why I was driven to work in academia. One of the main things is I had the opportunity to reflect and find out what I really value. And so during my PhD experience, apart from working in academic residences as well, I had the chance to do some work with developing curriculum and reflecting on just how my life has shaped so much based on some of the tremendous mentors in my life. I really found I really believed in education. And so what better place to work and to interface with students than the university. I get to mentor, but also learn from students. I learn quite a bit from them and from their journeys. And we also get quite a bit of freedom and flexibility to pursue our academic interests as well. And so I've got a slide in terms of what I do right now, but I'm happy to dive into this a little bit more during the question and answer period. This was a bit about how my past week actually looked like. So I teach. I've been developing a new course on drug delivery systems this past academic term, which has been a lot of fun. Also working with, this past week was a deadline for a grant renewal application, so I was working on that. And because of that, I get the opportunity to work with graduate as well as undergraduate students who are really excited about education and about developing. We've been doing a lot of video content development. We just shot an interview with a chocolatier in Purdy's. You say, where's that coming from? It links with crystal structure and materials, and so we've been doing a little bit of that. I sit on committees as well, so working on equity, diversity, and inclusion. And this past weekend, I had a chance to do some community outreach at Science World as well. So that's a quick taste of what I'm involved in. Happy to answer questions.
Okay, thanks so much, Dr. Lam. So as Laya posted in the chat, if you do have any questions for Dr. Lam or for any of our panelists as we go through the presentations, please start putting them up in the kind of Q&A section. We'll start answering the general ones afterwards, right? Once all four panelists have presented. So do start getting your questions ready. So we'll move on to our next speaker, which will be Dr. Xia.
Okay, great. So let me try to share my screen. Can you hear me? Okay, so thank you very much for this invitation. So my name is Brandon Xia. I'm a professor in the Department of Bioengineering at McGill University. So I have been asked to talk a little bit about my academic journey. So I got my undergraduate degree in major in chemistry and minor in computer science from China, from Peking University, and then I went to the U.S. To the West Coast, first to the West Coast to Stanford, got a PhD in chemistry with a specialization in computational biology. And then I went to the East Coast to progressively colder and colder places to New Haven, Yale, and did a postdoc in bioinformatics. And then I moved north to Boston, became a junior faculty in bioinformatics, chemistry, and biomedical engineering at Boston University, and then moved further north to McGill back, I think this was 7 years ago, and where I stayed ever since in the Department of Bioengineering. So I guess in a nutshell, it's pretty much a random walk all over the world. But there is it's sort of more of a biased random walk. There's some constant themes. I like computers, I like molecules, and those interests have stayed with me ever since. So my current research really has to do with computational modeling of molecules of interest in biology and in life science and engineering. So that's what I want to talk. That's what I spent a little bit of time to talk about. I also want to say that I also wear the hat of the graduate program director of biological and biomedical engineering here at McGill. So I'll also be happy to answer any of your questions about about graduate schools and graduate programs. So what I'm really interested in these days and very excited about these days is to think about how to build a model of the cell. I mean, in many ways, bioengineering is very different from traditional engineering field. You know, in any other engineering fields, you want to build an airplane, you first have a model, working model of the airplane before you build it. But in bioengineering, in particular, molecular and cellular bioengineering, we're in this kind of sort of a black box. You know, we don't really understand how the cell works. It's just way too complicated, and a lot of what people are doing are just tinkering. You know, you're tinkering with existing molecules and cellular systems. But ultimately, I think they like programming. They like to use computers. Great. They may or may not know a whole lot of biology. That's fine. But then there's also another population of students. They know a lot of biology, but now they want to get more into this quantitative, data-driven type of thinking, which I think is also great. I think they both contribute in a different way into this interdisciplinary, area. And I think that the field is big enough to accommodate both types of students.
Okay, thank you very much.
Thank you.
So our next panelist is Dr. Musavi.
Hello, everyone. I suppose you see my slides, correct?
Yes.
Yes. And Dr. Gabriel, I really appreciate if 1 minute left, you raise your hand, something to let me know. If I can have a senior discount to speak longer, that would be great too.
No problem.
Okay. With no further ado. Since colleagues introduced themselves a little bit where they have come from, okay, I made this a slide, just one slide to say where I have come from. Who am I? Well, I was a geek as growing up, and as soon as I entered university, there was a war between Iran and Iraq. I was in Iran, by the way. Therefore, I rushed. Universities were closed. I rushed to the front zones. I was curious, young, naive, and I thought that I was invincible. Nothing can hurt me. So I did go to the hospitals to learn first aid, and then went to the war. But the scenes that I observed over there, which there is no time to talk about those experiences, in a way changed my life. I was an electronic engineering student, and there was no way I could change my pathway. But at that time, I decided to become a biomedical engineering later on, if I were given the opportunity. And therefore, this picture shows that I was quite interested and lenient toward instrumentation, medical device instrumentation. And of course, by default, I was very interested in physics and science and so on. So I started my master then in Calgary, University of Calgary, then PhD at U Manitoba, then postdoc in Hopkins, and then went back to Manitoba as an assistant professor. That now I'm a full professor there. As I said, I'm a senior person over there. And I was happily doing signal processing, medical devices instrumentation. Basically, biological signal processing was my expertise. It still is. But since my mother got Alzheimer's, that provided another path. And I started to educate myself in neuroscience and cognitive science, and to come up with a technique so that we can diagnose Alzheimer's at the very earliest stages, before even clinical symptoms become apparent, and then offer treatment at that earliest stages. That's why that I included these two pictures to show that my major focus at the moment is on dementia studies, Alzheimer's diagnosis, treatment. But I go chronologically by the time being what we are doing. Before starting to say what my labs are about, I should also say that one of my heroes is Dr. Paul Bakirita. If interested to know who he is or what some cool inventions he has done, just Google him, and Google, for example, keeping balance with tongue. He has also another great invention that the University of Wisconsin after that has developed further, and that is to make the blind people to see. By the way, Paul Bakirita was a physician with an engineering mind. He was a ECE student initially, but then became a physician. To me, biomedical engineering is a bridge between engineering and medicine. And in fact, we are right that little rock in the middle. No matter how hard it is, we have to get on top of it. And of course, when you master on it, then you enjoy the view and enjoy the view of both sides of medicine and engineering. What I do, well, I run 4 labs. One of them, the main campus lab, is instrumentation. Then I have 3 other labs, which one is for respiratory acoustic, electrovesicillography, as well as TMS treatment. I briefly introduce what we do in each. First of all, in instrumentation lab, the application area has been respiratory swallowing disorder. In my previous life, I worked on those a lot, but then I focus on dementia, so I'm not working that much on the swallowing. I am mostly collaborating on that area. But still kept a major focus of obstructive sleep apnea diagnosis, even during the wakefulness, in a way we are predicting, and as well as some work slowly on its treatment. Sleep apnea is sort that causes people as they sleep to cease breathing, and it can be associated with a lot of other disorders, and it can cause quite fatal accidents as well. The very early work that we started was to come up with a technique that we use only respiratory sounds, breathing sounds, and detect sleep apnea during the sleep, without people to have to go to the sleep lab to stay there and record tons of different devices. What I describe our work as signal processing is like this. We cook breathing sounds and then do hocus pocus, abracadabra. We come up with 2 classifications, predict whether a person is OSA, obstructive sleep apnea, or non-OSA. And the reason that I came up with this slide is something interesting to share, especially with the student. The very first time that I presented our work in for the audience, who were majority were physiologists or medical physicians, after I finished, I thought that, gee, I gave such a good talk and I explained everything clearly. After I finished, one of the physicians raised a hand and said, "What did you talk about? That hocus pocus that you said, was that frequency?" And it was like pouring a bucket of cold water on my head, that no matter how much I thought that I did well, obviously I didn't connect to medicals. So I learned, okay, I explain it this way. Yeah, there are some hocus pocus for people who do not know signal processing, but there are sophisticated signal processing, including a support vector machine, machine learning, all of that. But of course, we have to know physiology behind it in order to come up with the diagnostic algorithm. Also, at the same time, we work on the hardware. That we started with a very simple device, then this little cute one that you are seeing. It is the 3rd version. The 4th version, which is a handheld device for physician, is in the progress too, with the CIHR funding. And as I said, we use advanced signal processing, and we have achieved 90% accuracy, more than that, by just analyzing a few breathing sounds during the wake time and predicting whether a patient will have apnea when they sleep or not. We work a little bit on other instrumentation tool, like designing a very tiny device to put on a mouth guard inside the mouth, and we record the oxygen saturation, for example, instead of that fingertip device that is currently in the market. Another instrumentation that I can talk about is a smart toothbrush. We designed it for dementia patients, because one of the things that patients go to the institution people give up on their patients to stay home is when they cannot do their hygiene and bathroom functions. So we started to develop a smart bathroom to help patients so that they can stay at home longer. And this smart toothbrush is one of them, and it is still a work in progress. I also have a lab for virtual reality in which we investigate the spatial cognition of our brain. The main goal is to diagnose Alzheimer's at the very early stage, and then provide some neurorehabilitation for Alzheimer patients or dementia patients in general. So that's our virtual reality. People, it is in immersive mode. It has non-immersive mode as well. They sit in a wheelchair and then walk in a virtual building. Let me show this quick video. It is a CUBEC building. Everywhere is the same. And as you see, people walk with that wheelchair. That wheelchair has been designed to become a joystick, basically. One of my brilliant students, who is now a chief scientist at Facebook and is making a lot of money, by the way, he designed it. He installed a microprocessor behind the wheelchair. And then people don't, why wheelchair, by the way, if you're asking? Because we, older adults or anybody actually older than 40 years, we get motion sickness if we are navigating in virtual domain. So we designed this wheelchair so that they receive a vestibular stimulus so that they are not getting sick in the virtual domain anymore. This is some result that I'm showing you. I'm showing that everybody's spatial cognition deteriorate by aging. However, Alzheimer and dementia patients actually fail that test so miserably. And it is such a good test to detect the early onset of the Alzheimer's. And these data is based on people for more than 400 people in this graph. Okay, so we use VR spatial test for diagnosis. We have another lab dedicated to ESG for also diagnosis and monitoring. We have RTMS treatment, another lab for TACS and cognitive exercises treatment. Our ESG lab is an international lab with, in collaboration with Australia, and it is quite a sophisticated technique and application. Basically, we put electrodes inside the external ear and then analyze the signals, and from those signals we have been able to not only to diagnose Alzheimer's but also separate Alzheimer's from mixed group, because most of the time patients with dementia are a mixed etiology, mix of Alzheimer's and vascular. And why is it important? Because not everybody, for example, get benefit of the RTMS treatment. And if we have a way to predict which treatment is best for which patient, that would be great. And that's what we are working on. I told you that those war scenes that I saw changed my life forever. And then also my mother's Alzheimer's, because I'm very impatient. But whatever we design or do, I have to see its immediate application on people. So we are working on it, that we have a technique that we can predict the response of a patient to a treatment so that we can offer optimized, personalized treatment. This is the RTMS treatment. It is a simple device in a way. It has large capacitors, creates an electromagnetic field. We hold it over the scalp. We zap the brain by pulses. The pulses are like a woodpecker poking to the head. It feels like that. And we hope that it can stimulate the neuron, and therefore we hope on brain plasticity of the brain so that it becomes, eventually we fight with the Alzheimer's devastating impact on the brain.
So Dr. Moussavi, can we just wrap it up in one more minute?
Sure, I'm close.
Thank you.
Another technique for treatment is TACS, alternative current transcranial current stimulation. We apply it at 40 hertz, gamma hertz. Why? Well, ask me later, I'll explain why. And for 4 weeks every day. And we also designed an iPad game exercises. Most of it I designed. And then I love this particular one because it forces people to rely on geometry other than landmark clues. And here are some results to show that how effective the program is from baseline to the end. I'll pass these because there is no time. Let me stop on this one a little bit. I would say our mission is to train and inspire the future scientists and developers, people who can have ideas. Young people are creative, are brilliant, and I've seen so many of them, and I'm proud that I have a job that I can inspire and train these young people. We try to provide diagnosis for challenging medical condition, to provide the best available personalized treatment, and by developing technologies, by investigating their efficacy and continuously enhancing those. Last but not the least, thanks to my volunteers, the team members, although this picture shows just a handful of them. I would love to answer to any question that you may have. Thank you.
Thank you so much. Very sorry to cut you off. It's, I've just been told to stick to the schedule, but very interesting. So thank you for that. And so our last speaker before we get to the questions will be Dr. Carolyn Wagner or Wagner. And so you can share your screen. Then we'll open it up to questions.
Okay, I think we should be good. Okay, and just so you know, my little guy just woke up, so if you hear crying in the background, he's fine, but his nap just ended. It's his first birthday tomorrow, actually. It's just kind of crazy. So hi, I'm Caroline Wagner. I'm brand new to being a professor, so I guess you'll get the opinion and viewpoint of someone who doesn't have any idea what they're talking about, but that is okay sometimes. And this is the logo I made for my new lab, so hopefully I convey a little bit of what I do in this picture. So we're thinking about public health and global health, but we want to do so in a way that utilizes bioengineering strategies and biomaterials in particular. So the ocean here you see is actually a cross-linked gel. So basically it's combining my interests in biological gels with how that can affect disease transmission at large scales. So I think I'll tell you a little bit about my story and then sprinkle in aspects of my work. So I actually also did my undergrad at McGill. So I've sort of come home over the last few years. In terms of, I see some of the questions are about how to get involved. So for what it's worth, when I was an undergrad, I was involved in research during my first summer, just really by chatting with a professor whose class I took and working in his lab for the summer. And then once I was dedicated to the honors stream, which is thesis based, then about the last year and a half of my undergrad involved doing research in a lab. So that was really great. And I would definitely recommend that for people interested in grad school, because it gives you a bit of a taste of what that life is like. So interestingly, that research that I was doing was on particulate combustion. So we're studying how sort of combustion can operate when you're lighting things based on tiny little dust particles that are igniting things one by one. And it was really cool because that work was tested in microgravity environments because the dust would settle too fast on the ground. So that led me to doing microgravity flights and the vomit comet that you've probably heard of. So we're lighting these fires in an airplane as it's pulling approximately 0G. So that was a lot of fun and like really changed the course of a lot of aspects in my life. So I think that's going to be a theme, is that just do the cool things and you'll end up somewhere, and you probably can't predict now where it's going to take you, but it's not going to be a bad thing. So then after that, I decided I wanted to go to grad school. So I applied to 2 grad schools because I was probably not aware of what the actual process should have looked like, but in general, I think understanding a little bit more about the culture of different universities would have been a good strategy for me to take, although it's something that I was naive to and didn't do. But I ended up at MIT where I did my master's. I finished that in 2015. So I got there knowing I was interested in fluid mechanics because my combustion work was also fluid mechanics related. But at that point, I had figured out that I wanted to switch to things related to biology and to health. So I actually got in there thinking, well, maybe someone will be doing something interesting with blood flow, because I got interested in high Reynolds number flows, I guess also through the combustion work that I was doing. But I didn't really find a whole lot of people doing that. So I got introduced to some people working on things actually with mucus and saliva. And so I ended up doing way lower Reynolds number flows, but still fluid mechanics as related to the body. And then I stuck around and did my PhD. So I finished that in 2018. And while I was there, so I had a minor in bioengineering because I was co-advised during my PhD. So that's sort of how I've gotten my foot into the door from the mechanical engineering world. But there's tons of mechanical engineers who do biological and biomedical engineering stuff. So there's obviously a lot of overlap. So I guess also during this time, I went through sort of an existential crisis, and I felt like I was focusing on such a small little problem. And I think this becomes true for when you do your PhD. It's a long haul, and you're really, if you were to draw a map of all the things you could be thinking about in the world, what you're thinking about sometimes feels like just a little grain of sand in an ocean or on a beach. So I realized that I was pretty passionate about how the world works and how we can be applying these technologies to better as many people as possible. So that got me interested in concepts like development and public health. So I found myself just spending a lot of time auditing classes in the economics department about development and global health and public health. So I decided for my postdoc, I wanted to explore that a little bit more. So I sent out a bunch of emails, literally just to a bunch of random people who are working on things related to public health. And most people wrote back and said, "Why are you writing to me? You have a background in engineering. This is completely irrelevant." And one guy wrote back and said, "Great, I'd like to meet you." And I started there a little while later, and he's fantastic. I guess I was going to add, so the mucus work that I did during my PhD, I just wanted to say one other thing, which is that it involved particle tracking and diffusive processes, and it turned out there was tons of overlap with how we were thinking about discrete combustion processes. So just to say, there's a lot of mathematical and scientific overlap between seemingly distinct fields. So as I was going to say, this brought me to Princeton for my postdoc. So I was actually in the ecology and evolutionary biology department, but I was working with Brian Grenfell, who does disease models, and a lot of stuff in the public and global health departments. And so I started working on a bunch of modeling within host level. So thinking about how a disease is actually spreading within the host. So we did some work on measles, for instance, and then also population level. So person to person, and we did some work on dengue and respiratory syncytial virus. And then, as I guess you're aware, while I was just want to say that through this interest in policy, one option that I think is really interesting that I was actually planning, I would be doing that now if I hadn't gotten a job, was what's known as a science policy fellowship with MITAC. So if you are someone who's wrapping up your, you go to grad school and then you realize, I am interested in sort of the policy side of things, how can I explore this? This is a really interesting opportunity for postdocs. So obviously it's a little bit further down the road, but there's probably other things you can do earlier than that too. So this is just to say that if you're someone who's really interested in science, but also interested in how that gets translated into what happens at a governmental level, there are some really interesting initiatives to appeal to that. I have like the chat blocking what's coming up next on my slide, so that's why I keep messing up there. But anyways, as you're probably aware, during this time when I was studying disease, this coronavirus emerged, and this completely changed the course of all the work that was being done in the group, which is true for not only disease modelers, but a lot of scientists in general. So in some ways, it was a super bizarre thing that I decided to switch into this field. Like, a year and a bit before this global pandemic emerged, and it's undoubtedly shaped the course of my academic and professional life. So as I said, this really switched gears, and so we started working on modeling related to COVID-19. So it's because of some modeling work we did there that we published, and also I got involved in an organization called Delve that was convened by the Royal Society. It was in a policy capacity, so sort of like writing up reports that would advise different approaches that could be taken in mitigating viral transmission. So I found this all fascinating, and it was very strange in some ways to be working on this in real time with a problem that was so present for everyone in the world. And I suspect this is why I got a job in the end, if we're being honest. But yeah, so obviously this changed the course of everything I was intending to do and a lot of the work that I'm currently doing, but has been very interesting. And even though it's maybe in the context of one pathogen, I think thinking about disease modeling is actually still quite broad, and we can, if we can, improve what we know now, that makes us more resilient to anything we might encounter in the future. So as I was saying, this led me to my current place, which is working at McGill. So I started as an assistant prof in August. So I guess in terms of why I'm in academia, you're realizing now that it's not obvious why, because I told you I was about to do a policy fellowship. So I think that it's, as I think Dr. Lamb said, I think it's great to check out options along the way, whether it's an internship, a co-op, some kind of other opportunity. I think people should take the time to do that and figure out what you really want to do. But while I'm here, I think that academia is a pretty special job. It's not a 9-to-5 job, it's an all the time job. So you find a problem that you're interested in and you're thinking about it all the time. But if I want to hang out with my kid one morning, or, check out and do something else and then make up time at some other point, I can do that. And I love having that flexibility. And I don't think I'd be able to work in a 9-to-5 environment anymore. So that's something that I really love about the job. And working with students is far and away my favorite part of the job, including teaching. So it's really awesome to be in a position where I get to do both the research side and the teaching side. So I think I've been talking for 10 minutes. I'll stop there, and obviously I'm happy to answer questions during the panel.
Okay, so thank you very much, Carolyn, and thank you to all four of our panelists. So that was very interesting. We got a nice presentation of the kinds of things that everyone was doing from a broad cross-section of academia and research. So now we move on to kind of Q&A. So our panelists are here and are willing to answer questions, although I've been asked to kind of ask a few myself in a moderated discussion before moving on. I think there's a lot of excellent questions that are popping up in the chat here, so I suggest we just move on to that, right, and answer those questions. So perhaps something that would be good to get the conversation started. We have a question here that says, starting a research project seems like a very daunting task. We hear a lot about the outcomes and solutions that come from research, but I was wondering, how do you even begin once you have a question or idea? When do you start? And maybe I'll tack on to that, how do you find the will to continue seeing the project to its conclusion, so we get to those papers that the public sees? So broad question to get you started with whoever wants to tackle this.
I did already answer that on the Q&A. I'm not sure if my answers could be seen, by the way.
We can see your answer, but I mean, I think it's good to get different perspectives, right? And not everyone is monitoring the chat and the answered questions, so maybe that's still a good starting discussion point. Someone want to chime in?
I'd say, as someone who has no idea what my research program is yet, the thing that makes it less daunting is just that research changes in ways that you can't predict. It's going to happen over the course of grad school, and it's certainly going to happen over the course of my career. So I would say now I'm thinking about what I want to do in terms of what I know and what I'm interested in exploring, and that's what I can say right now. But I might meet some cool collaborator tomorrow and go down some path and think about something that I'd never thought about before. So I would say, like, get your training done, think about the questions that you want to ask, and then be open to exploring other things as you move forward.
Yeah, Yeah, I want to echo what Karen just said. You know, make sure that the question is interesting. You know, you don't want to work on a boring question. So make sure that your question is interesting. Have an open mind. Keep an open mind, because there are lots of there's lots of challenges out there which you can potentially work on. But also have the discipline to finish the project. I mean, I typically find that to be the hardest to do. It's always easy to start new things, but it's much harder to tie all the loose ends up. But that requires discipline, that requires academic maturity.
So maybe this ties into another question that we have here is for all of the panelists. What do you look for in a prospective grad student? So you were saying you work with all sorts of masters and PhD and postdocs. So when you're deciding who to work with, maybe what are you looking for in when you're selecting them?
I can jump in quickly. So the research that I do is pedagogical research. So it's slightly different and pivoted from what I did for my PhD. But I think generally looking for grad students or undergraduate students that I like to work with, I think resilience is a really important part. So being able to navigate challenges and kind of stick through for the long term, I think that's a really important quality, not just for graduate studies, but also for life in general, for a position in academia. I also think like a passion and a general interest, curiosity is also really important too.
Anybody else want to add to that?
I forgot what the question was.
Yeah. So the question is, because you work with graduate students and the theme of the session is research, and we have a lot of attendees here who are interested in getting involved in research. What do you look for in prospective graduate students, or maybe, you know, undergraduate thesis students, or people that you work with in your labs?
For me, and it's just a personal answer, for me, passion is the most important. Of course, the student has to have a good background. GPA is not everything, but a strong desire to learn and passion to learn, in my opinion, is everything. If somebody is passionate to learn something, they'll definitely learn it. I suppose everybody who gets to university and graduate is talented. Everybody is talented. And if I can teach myself, and as an electrical engineer, if I can teach myself neuroscience, for sure young students can do that. You can teach yourself anything you want, if you want to. So for me, that is the #1 quality that I look in the eyes and in interview when I look at the interview students for admission.
That's great. So maybe as a follow-up to that then, because this came up in the questions quite a bit as well, is what's the process? If you do have someone, like you say, who is passionate, who does have that kind of resilience and the discipline to maybe tackle one of these projects, how do they go about kind of approaching you and getting involved in a research project like this? Again,
for me, it is just as simple as sending an email. And if it is for graduate studies, or if it is for summer, well, again, I would say the student should write down the most important questions for himself or herself. And then if, for example, he or she is interested in my research areas, just send me an email and let me help them to narrow down the research that they can take that fits to their background. If it is an admission for graduate studies, that's a little bit different. I normally interview students online if they meet all the necessary background check, and then it can be admitted. Funding is always an issue, a challenge. However, there are ways to make funding too. I love MyTex. I'm not sure if students have heard about it or not. It is one of the most beautiful, the best program in funding agencies of Canada, because even a student can be his or her own industrial partner, and therefore students can generate their own funding if a professor doesn't have enough funding. A lot of my students have used this feature of the Mintax and paid. So the money comes from somewhere. If you are passionate again about something, you badly want to study something, well, don't worry about it. Just take the first step, contact, be persistent, and then the path opens up. That's all I can say.
That's great. Does anyone have anything to add, or should we move on to another question? Okay.
Really quickly, this might be helpful for those who are interested in applying for grad school. Something that helped me out when I was applying is actually looking out for scholarships and awards ahead of time. So if you're able to kind of put that in your bag and then to approach your prospective supervisors to tell them about how interested and how keen you are, but also to show that you've actually took that initiative to apply for a grant and then to secure something, because that requires quite a few steps as well. I think that's very helpful as well. So maybe look out for NSERC or CHR grants and then apply for those ahead of actually applying for the position.
Okay, thank you. So maybe changing gears a little bit is we have a good question here, which says a lot of the speakers have international origins or experiences, probably referring to your different academic backgrounds as well. And the question is, what brought you all to Canada / made you stay? I feel like many Canadian students actually want to leave and go elsewhere, with lots of exclamation marks. Does anybody want to kind of explain why they decided to settle in Canada? Maybe Dr. Scott?
I can go first if you want. For me, I just I came to Canada because of my children's father's job. It was nothing on my own decision. I had 2 little kids, and I had kids during my bachelor. So at the time of coming to Canada, I just followed my husband, and then I stayed home for a year because my daughter was just 3 years old at the time. And then after a year, I got bored at home, and then I started to do my master, and then PhD, and then continued. That was as simple as that for me. It wasn't a very conscious decision for me to come to Canada.
Yeah, I want to echo. It's the same. I mean, basically academics, they follow jobs. I just follow. At each stage of my career, I apply for jobs and I receive offers and I pick the best offer. So the fact that I move around the world is purely accidental. I simply every step of the way I just do an optimization step. I pick the best job that's available to me at that time. So I think that it's true that as an academic, you need to be prepared to move around quite a bit, just simply because there's a small number there are much smaller number of universities compared to companies, right? I mean, that's but on the other hand, you don't have to. I mean, it's not necessary to move around quite a bit. I mean, depends on what kind of, I guess, depends on the opportunities in academia, or if you're interested in industry jobs, depending on the opportunities in industry. I think these days, Canada has a unique advantage, at least in my field, in the sense that the entire AI revolution, the revolution in artificial intelligence, in machine learning is really happening, is actually led by Canada. And there's a lot of, in my field, a lot of the systems biology efforts are led by Canadian scholars. So I think that in the end of the day, I think that it's great to be able to explore the world. But at the same time, I guess that we do have this opportunity to go see the world. But at the same time, you really want to pick places which can advance your training and advance your science.
So one question I get often from my own students is whether they should go elsewhere to do graduate studies. With multiple kind of options, Is it okay to do graduate studies at the same institution you did your undergrad at, or should you go elsewhere, or why? Do you have any thoughts on that?
I've seen people being successful in both situations. So I think it really depends on what kind of offers you have, and you want to pick the best offer. You want to pick, for example, you want to choose the best supervisor that really you can do the best research, that kind of thing. Whereas location really is an accidental thing, But anyway, but other people may have different priorities.
No, I would agree. I'm glad I went away. Ultimately, I came back for a variety of reasons. My partner's from here too. This is where we wanted to raise our family. It's a very different social structure in the US versus Canada in terms of the support provided for people and families. But I think that Brandon's right. I think one thing I didn't realize was how important it is to find a supervisor that you get along with and who you can work productively with. It's a long road getting a PhD. So I would say go where you feel like you'll fit in best. MIT was a school that was very focused on applying the technology. What's your startup going to be? What's your patent looking like? Other schools are more focused on the basic science, and I think some scientists do better in some environments versus others. So figure out a little bit what the culture is like, but at the end of the day, if you're doing good work and you're publishing papers, like, people are going to be drawn and they're going to notice you no matter where you were.
And so this kind of ties in here. We have someone that that kind of posted. So it's great that you make the best offer, you go where the best science is done. What are the criteria that you use to evaluate this? How do you know that one offer is better than the other than, let's say salary, or where, what should you look for, I guess, to see which offer is the best? Any thoughts on that? So we had an idea, with the kind of research focus and whether you wanted to develop technology or do fundamental research. But, looking a PhD is a significant commitment of time, right? Several years. So it's a big decision. And, I talk to a lot of students who are very stressed about that decision. So maybe what are things they should be looking for when they are making that decision?
Okay, I can chip in here. Actually, that's a question that many of my master's students who go for PhD somewhere else ask me. Quite often they ask, what do you suggest? Which professor should we choose? And my answer to them, well, I ask them what the situation is, what is the seniority level, what is the juniority level, all of that. And when all other parameters are in par, if you as a student find really both research areas quite interesting, if you find some research area more interesting to you, then I would say go to it. Choose that one. There is not much question about it. But if the research area are both the same level of interest, and the two professors, advisors are at the same level, the level of funding are more or less the same. If it is so, then I would say interview your future professor. Go with the one that your gut feeling says you would like to do. And I say it based on the experience. I have told you I'm almost a senior, and I have had many PhD students, many master students. And the most success, and also for myself too, when I picked my advisor during the PhD, the most successful PhD experience is when the student and the advisor are quite close in terms of work habit, in terms of ideals and morals and excitement. I think everybody would agree with me. These people enjoy those PhD time a lot, and they can publish a lot more too. As opposed to go to a very cold type of relationship with a person. Not any two people can work together. Find out you can work with which one better. And there's nothing wrong with that. I myself, when I saw Dr. Schroeder, my PhD advisor, I saw him in a conference. I was in Calgary, and then I saw him, and with no question, I just felt I'd like to walk behind this man. That was that feeling that I had. And to this date, he's more than 80 years old. He's like my father, and still we are getting in touch. And to this date, I would say that I'm proud that he was my mentor, and I did my PhD with him.
So building on this, and so when you're selecting a position, it might be useful to understand what you're getting yourself into when you sign up for kind of grad studies. So someone posted a question here about work-life balance in academia. So whether as a kind of graduate student or whether as a professor, Carolyn said it was a kind of 9 to 5. It wasn't a 9 to 5 job. So what else should students know before signing up to do a PhD?
I think it's really up to you. For me, it's very important to maintain work-life balance. I'm not someone who's going to work 100 hours a week. Absolutely, under any circumstances, I would go crazy. I actually read a fantastic piece. I'm late to the game, but it's a professor at MIT, or she did her PhD at Harvard, now MIT, now she did Harvard. She called her assistant professor time the most awesome 7-year postdoc, where I didn't worry about getting tenure at all, and I just lived my life, basically. And she maintains, look, I had 2 kids in grad school. I can't work 100 hours a week. That's not going to work for me. Other people that I know are happy, like, you know, spending tons of time working, and that's what drives them, and that's what makes them happy. And it's really up to the person. So I would say it's not a 9 to 5 job. Don't go into it thinking I clock in, I clock out. It's not going to work for you. But at the end of the day, it's up to the person in terms of the balance that you need to be productive and happy, I would say.
Yeah, that's fair. Anything else to add to that?
Yeah, I think it's very different between different labs and between different fields. You know, for example, I'm a computational person, so computer people, they're usually late owls. You know, so I remember when I was a PhD student, you know, typically you get up at noon or something, you know, and then you go to bed at 3 a.m. or so, you know, so, you know, the entire thing was shifted. And then here's another funny thing is that it must be very, you know, sort of peculiar to my lab, that people actually go to lab to talk to other people. So if you really want to get work done, you stay at home. So you stay at home to get work done. Anyway, the whole thing is just not, I mean, it really depends. I think, you know, the nice thing about the academic life is that it's extremely flexible. I mean, you basically get to do whatever you want to do. But on the other hand, you also want to keep in mind that it is not the real world. I mean, you gotta have to finish at some point, and it's very easy to just lose track of that. You know, lose track of time, thinking that the graduate life is the entire world, but it's not. So you've got to still make progress and get to that finish line within a reasonable amount of time. Yeah.
All of this is bringing back memories of my own PhD, and I don't know if I like it, but thanks for that answer. Okay, so maybe kind of shifting just a little bit, because we got a number of questions here related to teaching. So teaching is part of the job of a professor, and some of you said that you enjoyed it quite a lot. So what about for graduate students? Are there opportunities to get involved in kind of teaching and participate in that part of academia?
For sure it is. As far as I know, almost every university has some courses for graduate students to teach, because professors go sabbatical, and then that creates an opportunity as a sessional instructor. In fact, when I was in my 3rd year of PhD, I remember I went to I walked to the office of my head of department. And I said, I love teaching and I want to teach a course. Give me that opportunity before I graduate. He said, who is your professor? I said, Dr. Schroeder. And he said, maybe you can teach with some junior professor. I said, no, either give me the whole class or none. I don't like to share. It was a little bit bold response, but I was very honest. I said it is bad for students to have 2 different instructors for one particular course. And I got my class of 136 students in the second year. It was quite interesting. I loved it though. So it is always possible to teach. And in my university, there's always sessional instructors that senior students take advantage of that opportunity.
Yeah, I would say that there's also opportunities, especially with the online transition and with, say, new courses developing. I personally am always on the lookout for graduate students or undergraduate students who have a heart for education and for developing pedagogical strategies or leaning into that area. And so I think there are people around in the universities. You just maybe have to keep your eyes and ears out for those.
And so maybe a follow-up to this, because I know a few of our attendees are interested in a career in academia. So while they are during graduate studies, do you think it's a good thing they get involved in teaching, or should they focus primarily on the research if their goal is to get a job as a professor?
It is one of the necessities, actually. Nowadays, getting a position is very competitive. And having a teaching background experience is quite a bonus.
Any diverging opinions?
Yeah, I mean, I think it's important to be good at both research and teaching if you want to be, staying in academia. That's what the academia person does. The research, teaching, and then service. It's unfortunate that I guess we don't teach students how to teach. So, but then ultimately, I think it's one of the essential qualities of academic faculty.
So building on that, so Dr. Lam, you said you're doing research in, pedagogy, right? So biomedical engineering education. And there seems to be more and more of these kind of education-focused positions popping up in academia, at least in North America. So we have a question here as to what kind of pushed you to go from that technical background into kind of education. And I guess as a follow-up, are you happy with that choice now that you're involved in that?
Yeah, great question. In fact, I think it was Dr. Wagner who mentioned an existential crisis during her PhD. And I had a lot of chance to reflect about kind of my values and what I think is really important in my life and what I'd like to spend time in. And one thing that I reflected on is just the amazing mentors in my life and how they had a tremendous impact on who I am and who I've become, how I look at life. And I really hope for the same thing to be kind of injected into the university environment as well. And so that has really spurred my interest in a teaching oriented position. And so do I have regrets? Not at all. I really enjoy what I do. And I'm surrounded by amazing students and colleagues as well. Dr. Potman is someone who I've had the chance to teach alongside as well. And so, UBC was a great environment, and yeah, I really enjoy that.
That's great. Thank you. Okay, so maybe kind of switching a little bit back to kind of technical research. So it says here, this is a common question I hear also, which is for an undergraduate student that wants some level of postgraduate work, would you recommend trying to go into a PhD directly, or should you start with a master's program? So different universities offer different paths, right? Some will require you to start at the master's level before transferring to a PhD. Some will let you enter directly. Any thoughts as to which one is the best path?
From my experience, it hasn't made a huge difference. Like in the grad program I was in, mechanical engineering at MIT had forced you to come in and do a master's first. Other ones said you enter PhD directly. If you leave early, you'll be given a master's, basically. My experience was the outcome was similar in terms of if you stuck around in terms of what you got at the end of the day. I guess the master's is nice because it is a bit of a shorter commitment and it gives you a little bit of time to assess to feel like you're assessing whether you like this before you commit to something longer. But I would say, like, if you're really interested in the program and the supervisor, I wouldn't be discouraged by whether it's a master's admittance or a PhD admittance.
Okay, so maybe I'll diverge a little bit then from the path that we're on now. There was a question here that asks about how difficult is it to commercialize technology that comes out of a research lab, and maybe that was answered kind of in the Q&A section here. But maybe as a follow-up to this is because biomedical engineering is a relatively young field, let's say compared to mechanical engineering or chemical engineering. What is your opinion of what the industry is like and the value of going to do graduate work if one intends to go someplace outside of academia? Is this something that will help you kind of land a job at biomedical engineering, or should research be focused primarily on R&D positions?
I would recommend everybody, if they want to go to industry, they should at least have a master perhaps, and then go to industry if they want to become entrepreneur. And there are means to help the student in that path too. How difficult it is to make a technology, get it to the commercialization. Well, I don't know what is the metric here. It is not a short process. It's relatively a long process. But if somebody is really want to become an entrepreneur, for sure it is possible. And they have to, and there, as I said, the technology transfer office of the universities are there to help. I have had students that, for example, to one of them, the one that who designed that toothbrush, he is not a PhD material. I suggested to him that, look, don't go to PhD, just make a company and continue this design and make it your, make a niche in that design. It has a market eventually. Well, he has a long way to go because initially he has to have a job in order to survive. He can't immediately make money by his invention, that a smart toothbrush. But it is possible. We have had many students who became entrepreneur after a master.
That's great.
I think also the graduate training is important, and in fact like a necessity to get into an academic position. But there's a lot of it that's so valuable and incredibly relevant to industry positions as well. So problem solving, leadership, and taking initiatives, kind of trying to find your path when something's not clear. I think that's really important, and it could be really valuable in industry positions as well. So seeing people who are entrepreneurs or who take on managerial positions in industry, I think those are all really important skills to have.
Okay, so as a follow-up here, someone posted whether it was possible to stay involved in industry while doing research. I think some of you talked about industrial kind of partnership. Can you maybe elaborate a bit as to what that looks like in academia?
For sure it is. I mean, a student can be part-time, for example, in master or PhD. I have had students who were full-time in an industry and then part-time doing either master or PhD. For sure it is possible. It's actually good. I personally welcome those type of students too.
Is there interest from industry to partner with academia?
For that, for sure, yes. Again, and there are matching grants for that too, but usually those matching grants is for full-time students. But some students can have an industrial project while they are full-time student. If the professor has one of those industrial funding.
Okay. Thank you. So we only have 5 minutes left. So I have a question here, which is, I don't want to say more loaded, but certainly kind of it seems like it's coming from some kind of experience from one of the students. So the student asked, I think many students sometimes feel that established researchers, like our eminent panel here, are a bit disconnected from current student experiences in terms of finding internships or applying for positions and going for interviews and lining up grad studies. And students can therefore be a little bit jaded towards all of the success stories that the professors tell them. So the question here is, what is one misconception or piece of advice that you feel students overlook or dismiss when trying to navigate their options after graduation that they really shouldn't be overlooking or dismissing? Maybe that was a roundabout question. So, you know, with all of the options, and you've been talking about all of these great options, maybe what's the best piece of advice that students should be kind of considering that perhaps don't always consider when navigating or deciding what to do after they graduate?
Graduate from what? Bachelor?
From their undergraduate degree, sorry.
Oh.
So when they graduate, they can go and find a job. They can go do kind of a master's or PhD in engineering. They can do industrial. They can do research, and it's a daunting kind of decision. So maybe if we can kind of streamline a bit, what is the piece of advice, the general best piece of advice you can give students when they are considering their options for after they get their undergraduate degree?
I would say consult with your parents. As cliche as it may sound, but it is a piece of advice that I would give. Parents usually know their children's capabilities and weakness and strengths. It's not bad to ask your mom and dad what they suggest.
That's good advice.
Everybody is different. Everybody's goals is different.
Maybe Gabrielle or Caroline, you unmuted yourselves. Do you have something to add?
Caroline, go for it.
Yeah, I guess my feeling would be just to realize that decisions aren't necessarily permanent, and just because you do one thing doesn't mean that's what you're stuck in for the rest of your life. And I don't think that's something that I had a good conception of in undergrad. So I would say if you go online and find 10 researchers whose stuff you're interested in and then figure out what their trajectory has looked like to get where they are, it's very unusual that everyone would have done exactly the same thing. Some people spend 20 years in industry, then come back to academia. Some people do all sorts of different things. So I would say, I don't know, at a certain point, you can't put too much pressure on yourself, right? You think you're interested in something, you try it. If it works for you, it works for you. If it doesn't, it doesn't. I, for instance, switched advisors during grad school. I realized it wasn't quite the right fit. I wanted to try working with someone else. It didn't like massively impact me. So yeah, just be open to change, and also, but confident enough in yourself to take the first step. And your path is not going to look like what you think it is anyways. So don't worry too much.
And Gabrielle, did you want to wrap up?
I was going to say very quickly, I echo that entirely in the sense that, you know, we often put ourselves, we give ourselves a lot of pressure to make the perfect decision. Most times life doesn't go linearly and as expected. And so having a positive attitude and being able to learn from whatever those experiences might be, I think is something that I would have told myself back in the day.
Okay, well, thank you very much. And on that note, we are out of time for this session. We didn't get to all of the questions that the attendees here were posting. I tried to focus more on the general ones. There were some questions specific to each of the speakers. I hope I'm not overstepping that those students that do have specific questions, maybe they can send you an email and kind of contact you with kind of follow-ups. So with that, I'd like to thank all of our panelists for taking the time today to come and have this very interesting discussion. I'd like to thank and congratulate the organizing committee for this conference. I know this is the first year this is running, and this is really fantastic to have the opportunity to do this. And they were organized. I got my marching orders kind of for these sessions. So it's really great. So I hope with that you enjoy the rest of the conference and have a wonderful rest of your day.
Yes, thank you, Dr. Potvin. That was phenomenal. We chose you for a reason. Everyone enjoyed. And thank you to the four of you for being on this panel. I think I learned a lot. A lot of students learned a lot. There was many questions, over 50 questions asked, as well as I know people were talking on the side. So thank you again for this. To all the students, reach out to the professors, Google their names, you'll find their information, and get your questions answered. We are now going to be moving into